Welcome to everyone. My name is R. Kumaravel. I am working as assistant professor in Department of Computer Science Engineering at Kamaraj College of Engineering and Technology, Virudhunagar. Now, I am going to discuss black box testing. These are the contents we will see one by one. What is meant by black box testing and types of black box testing. Then black box testing techniques, in which we will see equivalence partitioning as well as boundary value analysis. Next one, this is the introduction about black box testing. What is meant by black box testing? Black box testing is a method of software testing that examines or checks or verifies the functionality of the software system or application without peering into its internal structure or working. On the internal working, how they are working, they didn't concentrate. Only black box testing, only functionality only testing. It will check the functionality, and then black box testing is based entirely on the software requirements and specifications. This is also called as behavioral testing. Behavioral testing is emphasized on functional requirements of software. Then the black box testing enables the software engineer to derive sets of input domains, input conditions that will fully exercise all functional requirements. That full, what does it mean? It will check or it will verify all the functional requirements of the program. That is a main aim of the black box testing. As a software engineer is to check all possible conditions, all the conditions in the all working conditions or functional requirements of the program. It will check all functional requirements of the program. Black box testing, what are the inputs? The inputs given to the inputs are given to the executed program, how they are behaving, and it will check the black box verify or examines the all functionality of the program and will deliver the correct output of the program. Then black box testing attempts to find errors in the following category. First one, incorrect or missing functions, then interface error and errors in the data structure, internal data structure as well as external database error, external database access. These kind of errors can be identified by the black box testing. And then fourth one, behavior or performance errors can be identified. Initialization as well as termination. While we are terminating or initializing program, they will rise the error that is called as a initialization as well as termination error. Black box testing. In the test cases can be derived to answer the following questions. First one, how is a functional validity tested? Test can be validated functionally, and then how are system behavior and performance can be tested. Performance tested. The performance as well as system behavior can be tested using black box testing. What classes of input will make good test cases? What will be the input? What will be the input as well as what will be the output of the system? Is the system particularly sensitive to the certain input values? Similar way, how are the boundaries of data class isolated? Fifth one, what data rates or what volume, data volume can the system tolerate? The tolerance level will be identified by the black box testing. What effect will specific combination of data have on the system operations? These things will be identified by the black box testing. Types of black box testing: functional testing, another one is the non-functional testing, third one is the regression testing. Functional testing, what does it mean? Black box testing is related to functional requirements. It will check the functional requirements of the system. It is mainly done by the software tester, not the developer. Non-functional testing means it will check the performance, scalability, usability, that's called as a non-functional requirements. And then regression testing. Regression testing is done after a code fixes or upgrades or any other maintenance to check new code cannot affect the already existing code. Modify the new code means that it will affect the existing code. And black box testing techniques. This is the main techniques. One is the equivalence class partitioning, another one is the boundary value analysis, and third one is the cause and effect graphing. This is a equivalence partitioning. What is equivalence class partitioning? This is a black box testing or specification based testing technique in which we group the input data into the groups or equivalence classes. The techniques also known as equivalence class partitioning. It will not concentrate each and every input value. You can now use any one value from the group or class. We can select or any one value from the group or class to test the outcome. That is the main goal of the equivalence partitioning. We can maintain the test coverage while we can reduce the lot of rework as well as most important the time spent. It is not a time consuming process, it will take very less time to check all the code. Then this is a continuation of equivalence partitioning. An advantage of this approach is to reduction in time required for a testing due to lesser number of test cases, that is a main, and then it reduces the number of test cases without compromising the test quality as well as test coverage. In this technique, input values to the system or application are divided into different classes or groups based on the similarity in the outcome. This is a main important concept in this equivalence partitioning. Based on the similarity, we have grouped the test cases, that is a input. This is an example for equivalence partitioning. If you are entering age, it accepts only, the text box accepts age, text box accepts only 18 to 56 age, but equivalent partitioning means there is a range, group 1, group 2, group 3, less than 17 there is a one group, 18 to 56 there is another group, and then greater than 57, age is greater than 57, then third group. If we are entering some x age, that falls under first category or second category or third category. If we are entering the age is 18 to 56, that is a valid. If we are entering less than 18, that is a invalid category, and then greater than, if we are entering age is greater than 57, 56, that is a falls under invalid category, invalid group. Lesser as well as greater than, this comes under invalid group, that is a equivalence partitioning class. Next one, boundary value analysis. Boundary value analysis means the boundary value analysis is a black box testing, is closely associated with equivalence class partitioning. Once we focus on the values of boundaries, is boundary value analysis means there is concentrated only on boundary. There is a we focus on the values of boundaries, as it is found that many applications have high amount of issues on the boundaries. So we have to check on the check on the boundaries. Boundary means values near the limit where the behavior of the system changes in boundary. This is a very, very important one. Boundary means the values near the limit where behavior of the system changes in boundary. During boundary value analysis, both the valid input as well as invalid inputs are being tested to verify the issues. What are the issues available in the boundary value analysis, that will be checked. It is easier as well as faster to find defects, as the density of defects at boundaries is more. We have identified the defects in a very faster way, and overall test execution time reduces as the number of test data greatly reduces. Next one, the test cases generated during boundary value analysis are very small. Okay, this is example for boundary value analysis. The text box accepts only 18 to 56. If we are entering ages 18, 19, 55, 56, there is a, and then minimum value another one group, minimum minus 1 as well as maximum plus 1, 56 plus 1, 57 as well as, this is a boundary. Boundary value means this is a valid 18, 19, 55, 56, this is a boundary value. Less than boundary as well as greater than boundary. It will be checked by the boundary value analysis. If you are entering 17, that is a minimum minus 1, 18 minus 1, 17, that is a invalid input, as well as valid means minimum plus minimum, then maximum minus maximum, less than maximum. This comes under valid input, as well as invalid input test cases means maximum plus 1. If you are entering 57 or 58 greater than 56, that comes under invalid input. That is a beyond the boundary value. It comes under beyond boundary value or greater than boundary value. The value is greater than boundary value, so it is a invalid input. Next one, cause and effect graphing. Cause and effect graphing means there is also black box technique. The cause and effect technique is graphically illustrates illustrates the relationship between given outcomes and all the factors that influence the outcome. That is a important one. Next one is a Ishikawa diagram. Is also known as, is invented by the Kara Ishikawa or fishbone diagram because of the way it looks. It is generally used for hardware testing, but it is used in the software testing also. Usually it tests the external behavior of the system. The technique starts with identifying causes and effects of the system under testing. Cause and effect, that is a main goal of the graph testing. The cause is a distinct input conditions and effects is a distinct output conditions. Each condition forms a node in the cause and effect graph. These are all. C1 is a cause, C2, C3, C4. These are examples for causes as well as input conditions. This is effects is a output conditions. E1, E2, E3, E4, E5. These are output of the conditions, effect, cause and effect conditions. This is example for cause and effect graph. Okay, I conclude this topic. Thank you.